Salam, peace be upon you. My name is Muhammad Layiq Siddiqui, the father of Holophase. We begin with a single, simple promise we have been keeping through this entire episode. We are not telling a story about what the universe does. We are building a compiler, a timeless machine that takes raw comparisons and outputs only what can be publicly certified. So in this part 37, we do something that sounds emotional, but is actually brutally technical. We define what stable means. Not stable as in it lasts a long time. Time stories are forbidden here. Stable as in if we nudge the measurement a little, if we change the passport a little, if we look again with a slightly different instrument, do we get the same certified structure? Or does it shatter like a mirage? That is the whole point. Stability is not a vibe. Stability is an audit. And stability is the birth of things. Now let us weave our short what we have certified so far, because by part 37, this woven summary should feel like a tightrope you can walk. So far, we have enforced the Holophase oath. The only primitive is phi, written as phi from x to the circle S1, meaning cyclic comparability. Only differences delta phi inside licensed finite windows can be spoken. Absolute phi is mute. We extract local lifts phi tilde, define A equals d phi tilde, build finite jets up to an honest ceiling n max, collapse everything through invariance, certify topology and defects, compile derived readouts like effective dimension and geometry only through hard gates, and enforce compression into minimal invariant bases. Good. Now we can ask the haunting question that appears in every real science, every real engineering, every real human life. How do we know a pattern we see is not just a lucky shadow? How do we know it is not a face in the clouds? Because you know that feeling. You look up and the clouds look like a man's face. Eyes, nose, mouth. You point. Your friend sees it too. For a moment, it feels real. Then the wind moves one soft breath, and the face is gone. Nothing happened in a narrative sense. No drama, no cause and effect story. Just a tiny admissible change in the configuration, and the pattern collapses. So we do not call it a thing. Now imagine a carved face in stone. You walk around it. You view it from morning light and evening light. You step closer. You step back. You squint. You change cameras. You even scratch a tiny corner, and the face remains. That is what we mean by stability, and we can state it in the cleanest way possible. A structure earns the right to be called real if it persists under admissible perturbations, inside declared uncertainty budgets. That is it. And now we say it in Holophase language. We start with some certified structure S. It could be many things. It could be an integer defect charge, like a winding number we certify by integrating A along a loop. It could be a compiled geometric object, like a metric readout that we only allow if it is a function of jets and topology, and it survives invariance and overlap. It could be an invariant basis element, one of the minimal generators we just insisted on in part 36. Whatever it is already certified under invariance. It already survived bookkeeping changes, lift shifts, chart changes, cut relocation, all that. But invariance alone is not enough, because invariance is about how we describe. Stability is about what we feed the compiler. The world does not hand us the same raw input twice. Instruments have noise, passports vary, windows shift, calibration drifts. Even when we do everything right, the raw comparisons are never identical. So we must define stability as a rule for the compiler, not as a poetic feeling. Here is the mission, in one sentence, spoken as a vow. We define stability as persistence under admissible perturbations within uncertainty budgets without using time narratives. Now we make it so simple you can feel it in your bones. A stable thing is like a song you can recognize even if it is played on a piano, a guitar, or a cheap phone speaker. The sound waves are different. The quality changes. Some notes are muffled, some are sharp. But the melody is still the melody. An unstable thing is like a song that exists only because your phone speaker is broken in a specific way. Change the speaker slightly and the song disappears. It was never the melody, it was an artifact. So we need a melody test for structure. We are going to build it as 4 gates, and we will keep it in everyday language the whole time. Gate 1, the perturbation class gate. Gate 2, the robustness test gate. Gate 3, the uncertainty quantification gate. Gate 4, the replication gate. Let us walk through them like we are testing a bridge before we let people walk over it. We do not wait 10 years. We do not tell a time story. We test now. We apply known loads within known tolerances, and we watch what survives. That is stability. Now gate 1, perturbation class. This is where we stop cheating, because without this gate, anyone can prove stability by refusing to perturb anything. So we force ourselves to say, out loud, what counts as a fair nudge. A perturbation class is just a list of allowed little changes. Not big changes, not sabotage, not smuggling, just the kind of variation that naturally happens when we repeat an experiment, we use a second instrument, we redraw a boundary slightly, we sample at a slightly different rate inside legal limits, we recalibrate inside stated uncertainties, we rerun a reconstruction algorithm with a slightly different smoothing choice, still admissible. So we declare a perturbation class P. We say, these are the nudges we allow. And the critical discipline is this. Perturbations must be admissible. They cannot violate the Holophase rules. We do not introduce aliasing on purpose and then blame the structure for breaking. We do not change the windows so violently that we are not studying the same certified domain. We stay inside the passported, lawful neighborhood of the original claim. Gate 1 output is simple. A written perturbation class specification. That is the first audit artifact. Now gate 2, robustness test. This is the heart. We take the original raw input and passport. We run the full pipeline, and we extract the structure S. Then we apply a perturbation P from the class P. We get new data and a slightly changed passport. Then, and this is the key, we do not adjust the result by hand. We rerun the entire extraction pipeline honestly. We rebuild the certified domain. We re-extract jets up to the ceiling and max. We re-certify invariance. We recompute the structure. That new structure is S sub P, meaning S under perturbation P. Now we compare. If S is a discrete token, like an integer charge, then the test is brutally sharp. Either S sub P equals S exactly, or it fails. Because integers do not have close enough. If S is a real-valued readout, like a curvature scalar or a metric component, then we compare within uncertainty budgets. We do not require exact equality because real-valued measurements always carry noise. But we require they stay within declared bounds. And we also compute something that is one of the most important ideas in all of engineering, and it is easy to understand: the robustness radius. How big can our admissible perturbations become before the structure breaks? That radius is a number we can certify. A rock has a huge robustness radius. Tap it lightly, tap it harder, it stays a rock. A soap bubble has a small robustness radius, a small touch, and it becomes nothing. We certify that radius. Gate to output is a robustness report plus a robustness radius certificate. Now gate 3, uncertainty quantification. This is where we force ourselves to be honest about how sure we are. Because stability is not just it looks similar. Stability is it stays the same within declared uncertainty budgets. So we attach uncertainty to S and to S sub P. Let us speak it simply. We say our uncertainty on S is sigma S. Our uncertainty on S sub P is sigma S P. Now we choose a coverage factor, K. For everyday language, we can say K equals 2 means we want a strong safety margin. Then our stability test for a real valued quantity becomes the absolute difference between S and S sub P must be less than K times the square root of sigma S squared plus sigma SP squared. We will say it slowly because this is audio. Absolute difference of S and S under perturbation must be less than K times the square root of sigma S squared plus sigma S under perturbation squared. That is not mysticism, that is just the standard way to compare two uncertain measurements fairly. Gate 3 output is a UQ-corrected stability verdict. Now gate 4, replication. This is the final boss. Because even if we pass simulated perturbations, real life can perturb us in ways we did not imagine. So replication asks, can another team, another instrument, another window passport, still admissible, extract the same structure? And again, we are not telling a time story. Replication is not later. Replication is elsewhere. Another window, another instrument, another lab, another method. If the structure is real, it should not be loyal to our personal setup. It should belong to the world. Gate 4 output is a replication success report or a replication failure alert. And now we can say our Part 37 definition in one clean sentence. A structure is certified stable if it survives a declared class of admissible perturbations within uncertainty budgets and replicates across independent passports. Now we will ground this with examples across scales, because that is how we keep it human. First, the simplest human example. If you want to know if someone really knows a language, you do not test them by asking them to repeat one memorized sentence. That is a list. You test them by perturbing. You ask the same idea in different words. You change the topic. You add noise, background sound. You ask them to speak faster or slower. If they still understand and respond correctly, the competence is stable. If it collapses under a small change, it was memorization, not knowledge. That is stability. Now a physical example. Take a coin. You can look at it under bright light, dim light, from different angles, with a magnifying glass, with a cheap phone camera. The coin's structure, its stamp, its edges, its weight, persists. That is why you call it the same coin. Now imagine a glare spot on the coin. The glare appears and disappears with small light changes. You do not call the glare a thing. It is a measurement artifact. That is the difference stability makes. Now the scientific example that every listener can feel. A new discovery that appears only in one dataset, one analysis pipeline, one lab, and disappears under tiny changes is not a thing. It is a cloud face. A new discovery that appears in multiple independent datasets, survives calibration changes, survives boundary shifts, survives algorithm perturbations, survives different instruments. This becomes a thing. Now we can state the prediction of this part in episode 14 language. Prediction. Stable structures replicate across instruments and small passport changes. Unstable ones fragment and fail robustness tests. This is not a future prediction. It is a falsification footprint. It tells you what must happen when you run the audit. Now, let us define the falsifier. Falsifier: a claimed stable invariant that collapses under tiny admissible perturbations inside declared uncertainty budgets. In plain language, if you tell us this is stable, and then we give it a gentle nudge that you yourself said was admissible, and it breaks, then your stability claim is revoked. Now, because we are trying to keep this part both rigorous and simple, let us apply this to three different kinds of structures: integers, real numbers, and classes. 1. Integers, topological charges. These are our sharpest tokens. If a defect charge changes under a tiny admissible perturbation, something is wrong. Either the perturbation crossed the typed boundary, or we were not in a certified domain, or the extraction pipeline was illegal. Because topological charge is supposed to be protected, so stability here is extremely clean. 2. Real numbers, geometric readouts, curvature values, effective dimension values. These can wobble slightly, and that wobble is not failure. Failure is wobble bigger than the uncertainty budget, so stability here is a statistical test. 3. Classes. Not classes, linking classes, isotopy classes. Here stability is not the number stays the same, but the class stays equivalent. If our loop representatives change under perturbation, but they remain in the same isotopy class, the structure is stable. Now we bring in the most important everyday analogy for classes. A coffee mug is topologically the same as a donut. That sounds like a joke until you hold it in your mind, because both have one hole. You can reshape clay from mug to donut without tearing, as long as you do not close the hole. Now, if a tiny perturbation, like a small dent, made the mug become a sphere, you would know that the hole was not real. But it does not happen. You can dent the mug, and the hole remains. That is topological stability. Now, let us include one harsh and one beautiful example, just to make the difference vivid. Harsh example: mirage science. There have been moments in science history where people saw an effect that did not survive perturbations. Maybe the effect was near the edge of perception. Maybe the uncertainty budget was not honestly declared. Maybe the analysis pipeline was tuned to the noise. Under different observers, different instruments, slightly different setups, the effect vanished. Stability audit would destroy it quickly. Beautiful example: solid science. When something survives two independent instruments, two independent pipelines, and a huge range of perturbations, we trust it. Not because we worship authority, because the structure earns its right to be called a thing. Now we must stay careful. We cannot go into dynamics. We cannot tell cosmological stories. We cannot talk about over time. So when we speak of a particle, or a protein knot, or a market pattern, we speak only of replication across windows and passports, timelessly. Now we write the audit artifact in spoken form, not as a code block, because this is audio. Imagine we are certifying a structure token, S. We create a stability ledger entry. First, we write the passport ID, window ID, boundary masks, excisions, the certified domain D, coherence status gamma, identifiability rank, and Nmax ceiling. Second, we write the structure S precisely. If it is a charge, we record the loop system, the integral of A along each loop, and the integer result. If it is a geometric readout, we record the compilation recipe and the domain it is defined on. If it is a class token, we record the class criterion and the equivalence test. Third, we declare the perturbation class P. We list the exact admissible perturbations: noise bounds, calibration bounds, window boundary shifts, algorithm parameter ranges. Fourth, we run the robustness tests. For each perturbation, we rerun the pipeline and we record S sub p. We record whether it matches exactly, or matches within uncertainty, or matches by class equivalence. Fifth, we compute a robustness radius. We state stability holds up to perturbation amplitude R. Sixth, we record uncertainty budgets and the comparison threshold. We record K, sigma S, sigma SP, and the stability inequality. Seventh, we record duplication attempts across independent passports and we write pass or fail. Finally, we write the verdict: stable token certified or stability failed and token revoked. That is what we mean by audit artifact. Now we bring in the carry line because every part must leave the listener with one sentence that hits like a bell. Stability is the birth of things. Let us unpack that in the simplest possible way with no metaphysics. We do not first see things and then build science. We see patterns. Science is the method that decides which patterns deserve names. A thing is a pattern that stays put when you poke it within fairness. A thing is what remains after the world and the measurement and the passport are allowed to wiggle inside honest limits. This is true for rocks and electrons and words and laws. A rock is stable across many perturbations: different lighting, different angles, different touches. An electron is stable across an enormous family of experimental windows: different labs, different apparatus, different energies, different materials, and still the same charge and the same quantized properties appear. A law is stable across conditions: change the initial setup, change the instrument, and the relation remains inside uncertainty. If something is not stable, we do not promote it. We do not let it enter the ledger as an entity. That is our revocation clause, and we say it sharply. Revocation clause. Unstable structures cannot be promoted to entities. Any such promotion is revoked. In plain language, if you cannot show stability, you are not allowed to name it as a thing. You are allowed to report it as a candidate. You are allowed to archive it as an anomaly, but you are not allowed to build the next layers on top of it. Because if you build on mirages, the whole tower collapses. Now let us connect this to what we have already built in this episode, because part 37 completes a triad. Invariance filters out bookkeeping artifacts. Compression filters out redundant descriptions. Stability filters out fragile coincidences. So when something passes all three, it becomes certified public structure. And that is exactly where episode 14 ends in spirit. Structure is certified and nothing has happened. Only later layers, episode 15 and beyond, are allowed to talk about how stable things change, how they interact, how probabilities appear, how entropy appears. But those stories require things. Part 37 is where we earn them. Now, before we close, we do one mandatory stress test in words. We remind ourselves: stability is tested after invariance. So we do not confuse it changes under lift shift with it is unstable. If a quantity changes under lift shift, it fails invariance, and it is not even a candidate token. If a quantity is invariant but collapses under admissible perturbations, it fails stability and it cannot become an entity. So we keep the firewall clean. Finally, we close with the stability mandate in a single spoken paragraph, because this is audio. The stability audit suite is active. Every claimed structural token must declare a fair perturbation class, must survive robustness tests within honest uncertainty budgets, and must replicate across independent passports. What collapses under gentle admissible nudges is revoked as a mirage, not promoted as a thing. What persists earns the right to be named. Stability is the final certification that turns a pattern into public reality. And if you want to go deeper into the formal details behind this, because we are keeping the spoken version simple, our formal work is available on Zenodo. Search for Holophase, and you will find the mathematical papers that carry the full ledger discipline, the gate proofs, and the strict definitions. Part 37 complete. The ghost is gone, the thing is born. Stability is the anchor. Always, peace be upon you.